Welcome to another lecture on Mathematics 2, JNT Kakinada R20 Regulation, first year, second semester. Now, in this lecture, we are going to discuss about normal form and canonical form. So far, we covered what's the syllabus and what are the contents in that syllabus. In that one, especially we start with the unit 1, which consists of linear algebra concepts. In that one, what type of the matrices are available and which matrix is said to be vectored, and what are the operations that to be performed in this one. In this one, in matrices, we calculated the rank of a matrix by using echelon form. Till that we covered. Now in this lecture, we are going to cover normal form and PAQ equal to normal form. Both the concepts we may cover in that. This even this is also normal form is also used to compute rank only. Then what's the major difference between the rank of the exact canonical form and normal form is both are similar, but in the normal form we are using both the row operations and column operations simultaneously. Row and column operations simultaneously. That's only and major difference between echelon form and normal form is in the normal form I make it a diagonal matrix, especially multiplicative identity. Multiplicative identity matrix. Whereas in echelon form, we make it only upper triangular matrix. Upper triangular matrix. Even here also, rank is nothing but number of non-zero linear independent rows or columns that will take care. Earlier, only number of non-zero linear independent rows only, because I used only elementary row operations. Here I am using both row and column operations simultaneously. So that's the reason the definition in the normal form is the number of non-zero linear independent rows or columns can be taken here. So if the procedure, if I go through the procedure also quite similar to the earlier. Will be given a matrix to you, matrix A of size m by n will be given. This matrix A is reduced to diagonal matrix in this process. I used both row operations and column operations simultaneously. Here same logic. First we need to identify, we need to identify A11, A22, A33 and so on. Then by using row operations, elements below A11 must be 0. Similarly, by using column operations, elements beside A11 must be 0. So elements below and beside must be 0. Means if I write this one here, suppose A is a matrix, that's A11, A12, A13 and so on, A1n, A21, A22, A23 and so on, A2n, A31, A32, A33 and so on, A3n and so on, AN1, AN2, AN3 and so on, ANN. This is the given matrix. Now in this one, first I need to identify here what is A11, what is A22, what is A33 and so on, what is ANN. That is the first step as per our discussion. We need to identify. Then next case, by using A11 I need to make, that means here by using A11 especially operation is elementary row operation. Elementary row operation. As for this, I supposed to get A21, A31, A41, and so on. AN1 equal to 0. That's what. So this is the first one. And the second, same by using A11 again, and the operation is elementary column operation. Elementary column operation means here this is A12, A13, A12, A13, A14, E and so on, A1n equal to 0. So that's a major difference in between. So at the end of the two steps, first two steps, here I make it the matrix is A11, 0, 0, 0 and so on 0. These are the elements would be 0 and A22, A23, A24 and so on, A2n, A32, A33, A34 and so on, A3n, A42, A43, A44 and so on, A4n and so on, AN2, AN3, AN4 and so on, ANN. So this would be the shape at the end of the first two steps. This would be the shape at the end of the first two steps. So by using this A11 we made these elements 0 by using the column operations, and these elements yeah, 0 by using row operations. By using row operations, these elements must be 0. That's what. Now, similarly, the same procedure extended to this one and this one and this one and this one and so on. The same process is extended to here. The same procedure is extended to A22, A33, A44 and so on, ANN. So that finally we left with only principal diagonal elements. Principal LE diagonal elements. Principal diagonal elements. In that one, sum may be 0 also. In that, sum may be 0 also. So, the finally I may be here with A11, 0, 0, 0 and so on 0, 0, A22, 0 and so on 0, 0, 0, A33 and so on 0 and so on 0, 0, 0 and so on ANN. This would be the process. And here what I need to do is further divide once again. So the last operation is A1 R1 A. The last operation here R1 primes R1 by A11, R2 primes R2 by A22, R3 primes R3 by A33 and so on. Rn primes Rn by ANN or C1 primes C1 by A11, C2 prime C2 divided by A22, C3 prime C3 divided by A33 and so on. Cn prime Cn divided by ANN. We make it this one. So the final form would be like this. Therefore, A equals to 1 0 0 0 and so on 0, 0 1 0 0 and so on 0, 0 0 1 0 0 and so on 0 0 0 0 and so on 1. That's what. So this one is further represented as IR0 0 0. This R indicates here. This R indicates a rank. R is rank of A. R is rank of A. Here we may get some confusion that, for example, if I have this A 3 by 3 and the final matrix is I got like this 1 0 0 0 0 0 0 1 0. If it is like this one, what I need to do is I suppose to rewrite this one as 1 0 0 0 1 0 0 0 0, which is I2 0 0 0. We suppose to write like this. Or suppose still, I mean to say that here I suppose to use two operations as one operation here, simply by switching R2 to R3, R3 to R2. By switching R2 to R3, R3 to R2, that we suppose to write here. For example, here if it is 1 0 0 0 1 0 0 0 1 I have, then even this one I am writing I3 0 0 only. It doesn't mean that, oh, there is no zeros means there is no 0 rows means you are not authorized. No, no, you supposed to write this one. You supposed to write this one here. Okay, so I3 0 0. Now let us see a problem on this. Now say this here. The normal form definition. Normal form is said to be here IR0, IR000, or even in the column format we may write, or row format we may write simply IR also. In generally, the known tradition is this, so that's the reason I usually prefer this one. You please kindly prefer this one only. Where IR is an identity matrix of order R, so rank of normal form is order of the identity matrix. That's what we discussed. So to reduce the given matrix into normal form, we need to use elementary row and column operations. Then if I see this here, let me try this one for you. Now if I see this one, a matrix, clearly it is 4 rows and 4 columns, so 4 by 4. Now by using this, I need to reduce this one and this one to 0. That means I supposed to check R2 primes, R2 based on R1, and R3 primes, R3 based on R1. Why I am not choosing the R1 here? Why I am not choosing the R4? Because R4 already 0. Our intention is supposed to reduce to 0. So already 0, that's the reason I am not disturbing R4. So here is -2. If I can get here 2, means R2 is supposed to 2. That means I is supposed to multiply with the 2. Then add. So here also multiply R3 with the 2 and then add, I may get it. So A will be -2, -1, -3, -1. These two I made wantedly 0. Fourth one already 0. So means here fourth one not altered. So I'm writing as it is. Okay. Now what I did here, I multiplied this with 2 and then added to this. So 2 2s are 4, 4 plus 1 3, 4 minus 1 3, 3 2s are 6, 6 minus 3 is 3, -2 minus 1 will be -3, and here 0 minus 1 -1, here 2 minus 3 will be -1, here 2 minus 1 will be +1. So at the end of the first operation, I may get this. Again, I supposed to check with the same. Let me use the different color. With the same, I supposed to check -3 -1 -3 this to be 0. That means I need to use the column operations. So here I need to change C2 primes C2 based on C1, again C3 primes C3 based on C1, and C4 primes C4 based on C1. What the operations I may get here? Here it is -2. So if I get +2 means multiply this with the 2 and subtract because both are having the same sign. Again C3, it is here minus 2, here it is minus 3. So the common junction is because both are relatively prime to each other. 2 and 3 are relatively prime to each other. In that case, you just multiply this coefficient with that and that coefficient with that. So I may get here C3 with the 2, C1 with 3. Since both are having same sign, so subtract it. Similarly, C4. Here is minus 1, here is minus 2. So multiply this with the minus 2, C4 with the minus 2 and add. Otherwise, multiply with the 2 and change the sign here, subtract. Let me write down clearly to you. So C4 here if it is minus 2, then it should be plus 2. If it is already minus 2, I need to make it plus 2. That means minus 2 is supposed to multiply. That's the reason I'm multiplying with the minus 2 and adding to this. So if I do this one, what happened here? Let us check. Yeah, minus 2, 0, 0, 0. These we made 0 already. With that, what is the convenience here? See, in this already, the remaining C1 are zeros. This is, I missed some change sign here. They both are same means minus, right? So here C2 will be 2C2, C3 will be 2C3, C4 will be minus 2C4. So I can write here C2 will be 2C2. That means 6 minus 2, 2. C3 will be 2C3. That means here 6 minus 2, 2. C4 will be minus 2C4. So minus means plus 6 minus 2 plus 2. This I'll get here. So this is at the end of the second operation. Now elements below the A11 and beside the A11 are 0. Now I need to move from here to here. That means I need to change R2 and R3. Sorry, R3 and R4. So R3 primes, R3 based on R2, R4 primes, R4 based on R2. So what I may get here? Here is already I have 6 at here. So if I make it minus 6, it could be easy. So that's the reason multiplying with the 3. So it will be minus 6, then add. Here plus 6, here if it is a minus 6, that means multiply with minus 3. Add. That's it. So I may get here R3, R4 only updated. So means R1 and R2 will be as it is. Minus 2, 0, 0, 0, 0, 6, 6, 6. Some people they may try here. They want to divide the second row with the 6, third row with the minus 2, fourth row with 2. Yeah, you can do that too. That one also. That's also not a mistake. But I'm not willing here. If you want, you can perform, but I'm not willing. So then third one. Already these two we made 0 earlier. Now these two we made 0 now. Remaining here. What I make it? Since all are the same, blindly I may get zeros. Don't expect it may be happen always. Here it was happened. Now below is 0, so beside I supposed to get that. So I need to check R3, sorry C3, C3, C3 based on C2, C4 based on C2. So here is both are same means only change the sign. Only change the sign. So we'll be getting here minus 2, 0, 0, 0, 0, 6, 0, 0. These two already we made 0, now we made this 0. And what may happen here? Since both are 0 minus 0, 0. So I left with this finally. So finally I left with a diagonal matrix. The meaning of the diagonal matrix is all non-diagonal elements are 0. All non-diagonal elements are 0. It doesn't make a sense that, oh, all the non-diagonals are 0 means diagonals need not be 0. Diagonal can be 0. Now, here I need to get this one to 1. I need to get this one to 1. Here, multiple options will be there. One is I may try dividing with row 1 with -2 and row 2 with 6, or column 1 with -2 or column 2 with 6. Either is fine. So let me check with the column. C1 primes here. C1 primes C1 by -2. C2 primes C2 by 6. So I may get here -2 by 2 will be 1, 1, 0, 0, 0, 0, 1, 0, 0. Remaining all are zeros. So I may be left with this here, and this one I can rewrite here IR I 2 0 0 0. So a rank of A is defined here 2, because this is, it consists of only 2 independent rows or 2 independent columns, linearly independent columns. That's what the meaning of that. You please practice these list of problems. Pause this video for a while and note it down, and complete this as. So in this one, a rank of a matrix directly, the method is not specified. That means you may check directly by determinant method. That means by examining the minor. Examining the minor, we make it here. Even I may use a calculator. Right now I have the emulator of the 991 ES Plus. First, this for our verification only. Directly first I need to set up the matrix here. The matrix is 6. Then I need to define a matrix, matrix 1. It is of size 3 by 3 because it allows a 3 by 3 only. Oh, again I made a mistake here. 6, matrix 1. 3 by 3 means 1. I need to opt 1. So 1, 2, 3, 3, 4, 5, 4, 5, 6. Now I need to find its determinant. So for that one, shift 4, I make it a matrix. Data dimension. So if I go with the data 2, matrix means already I have this. Okay. Now already in the matrix notation, matrix mode, because mat, mat. So shift 4 I'm using. What I need to find here, determinant I would like to find. Determinant number is 7. So opt 7. Again shift 2, shift 4. The matrix I entered the data in the 3, matrix A. So matrix A is 3 option. Close the bracket and press equal to. Oh, fortunately we got the determinant is 0. That means its rank is not equal to 3. Its rank is not equal to 3. Then by the time, what I need to do is we need to choose any minor. For example, if I cancel this particular row and this particular column, this particular row, I make it sure this minor is 4, 5, 5, 6. So 4, 6 are 24 minus 25, which is -1, but condition is not equal to 0. Whether it is a positive or negative, it doesn't make a difference. So not equal to 0 means its rank is 2. In the same sense here. Similarly, this one also. Here 4 by 4, here 3 by 4, 3 rows, 4 columns. I may cancel any particular column and find the determinant. Here it is non-null matrix, but only one element is non-zero. So blindly I may write rank is 1. Now it is specified very clearly that reducing echelon form. Echelon form means by using this element must be 0. Next I need to jump from here to here. by using this element must be 0. Next, by using jump from here to here, reducing this element to 0. At this position, how many number of non-zero linear independent rows are there? I need to count and specify that same way. But here a k is given. Find k if rank A is 2. Rank A is 2. Rank A is 2 means for my convenience, I would like to bring this one to interchange these rows. R3 as R2, R2 as R3. Then I will find the echelon form. In this process of echelon form, all these position will be 0, but it is already given to means in this position whatever the values that should be equated to 0 and simplify. That's one technique. Another technique, you take a minor which consists of k and then equate it to 0, you may get it. So like that multiple ways are there. Now similarly, reducing into normal form. The normal form is minus I think, is this we tried? Yeah, I think so. This one we tried. Like this, similarly we can go with the other problems. And next concept is I need to extract the two non-singular matrices P and Q from this by reducing this into normal form. Just let us see that one. We'll see that in next lecture.